When we picture alien life, we picture it far away. Another star, another galaxy, a faint signal crossing thousands of years of empty space to reach us. But there are two places we almost never think to look, and both are startlingly close. One is the cluster of worlds orbiting our own sun. The other is the planet beneath your feet. Because here is a possibility most people never consider. Alien life may not only be out there. It may already be here, on Earth, hidden in plain sight, and we wouldn't even know. Let me explain how that is actually possible, and then let me take you on a tour of the nearest places life could be waiting. Start with the strange idea at home. Every living thing we have ever studied, from the deepest bacterium to the blue whale, runs on the same basic machinery, the same genetic code, the same handful of building blocks, the same chemistry. That uniformity is usually taken as proof that all life on Earth shares a single origin, one ancestor, billions of years ago. But it might mean something else. It might simply mean that we have only ever found one kind of life, because our instruments are built to detect that kind and no other. In 2005, the philosopher Carol Cleland and the biochemist Shelley Copley gave this blind spot a name, the shadow biosphere. The idea, later developed by Paul Davies, Stephen Benner and others, is simple and unsettling. If life can begin from ordinary chemistry, and if it began once on the early Earth, why assume it only began once? A second genesis, a separate origin of life with different molecular machinery, could have arisen here and could still be here, mixed in among the microbes, invisible to us, because every test we run is designed to find life like ourselves. This is less far-fetched than it sounds, and the reason is what we have learned about how tough and varied life can be. We have found microbes thriving in boiling acid, inside nuclear reactor pools, kilometers down in solid rock, in pockets of brine far below freezing. We have also learned a humbling fact. The overwhelming majority of microbial species on Earth have never been grown in a laboratory. They appear only as fragments of DNA in soil and seawater, organisms we know exist but have never actually held. If our catalogue of ordinary life is that incomplete, then a form of life that does not even register on our standard tests, perhaps built on mirror-image molecules or a different set of chemical letters, could sit in a spoonful of desert crust or deep-sea mud, uncounted. No shadow biosphere has been found. But the honest position is that we have barely looked, with tools that were never designed to see it. And finding even one would change everything, because if life started twice on a single planet, it is almost certainly common across the universe. Hold that thought, because it reframes the whole search. If life is simply something chemistry tends to do, given water and energy and time, then the nearest examples might not be light years away. They might be light minutes away, on the other worlds of our own solar system. And over the last 20 years, those worlds have stopped looking dead. Begin with the obvious one. Mars today is a frozen desert, scoured by radiation with almost no air. But Mars was not always like this. 3 to 4 billion years ago, it had rivers, lakes, and possibly a shallow sea, at the very time life was getting started on Earth. NASA's Perseverance rover is exploring Jezero Crater, a basin that was once a lake fed by a river delta, exactly the kind of place that would preserve chemical traces of ancient life, if any ever existed. And Mars holds a genuine live mystery, methane. Down on the surface, the Curiosity rover has repeatedly detected methane, a gas that on Earth is produced largely by living things. It rises and falls with the seasons and occasionally spikes. The puzzle is that Europe's Trace gas orbiter, circling overhead with far more sensitive instruments, sees almost none. Curiosity detects it, the orbiters do not. Nobody yet knows whether the answer is slow leaking geology, a quirk of the measurements, or something stranger. It's not proof of life. It's an unsolved question sitting on another planet right now. Settling it may come down to the rock's perseverance has been collecting. The rover has sealed dozens of carefully chosen samples in metal tubes and left them waiting on the surface, the first stage of an ambitious plan to fly them back to Earth, where laboratories could examine them in ways no rover ever could. But that plan has just hit a wall. The cost climbed past $11 billion, and in early 2026, the program to retrieve those samples lost its funding. For now, the tubes sit on Mars with no confirmed ride home, while China presses ahead with its own sample return mission, raising the real possibility that the first pieces of Mars ever brought to Earth will be Chinese, not American. The samples that might finally answer the oldest question about Mars are cached and ready. We simply have to go and collect them. But the most promising places for life that exists right now are not on Mars at all. They are the ocean worlds. Jupiter's moon Europa is a ball of ice slightly smaller than our own moon, and beneath that frozen crust, kept liquid by the constant flexing of Jupiter's gravity, lies a global ocean of salt water. By the best estimates, it holds roughly twice as much water as every ocean on Earth combined. Liquid water in the dark, in contact with a rocky seafloor for billions of years. That is the recipe. In October 2024, NASA launched Europa Clipper, the largest spacecraft it has ever built for a planetary mission. It is on its way now, due to reach Jupiter in 2030 and make dozens of close passes over the moon. It will not by itself find a fish. What it will do is measure whether that ocean is genuinely habitable, how deep it is, what it is made of, how thick the ice is, and whether the chemical ingredients for life are present. And then there is the world that has quietly become the best laid of all. Enceladus is a small, brilliant white moon of Saturn, only about 500 kilometers across. It too hides an ocean beneath its ice. But Enceladus does something extraordinary. It sprays that ocean into space. Through cracks at its south pole, towering geysers vent plumes of water vapor and ice grains hundreds of kilometers high. And the Cassini spacecraft flew straight through them. In those plumes, it found salt. It found a startling range of organic molecules. It found molecular hydrogen, which is a usable source of energy for life. And in 2023, a fresh analysis confirmed phosphates, one of the essential ingredients of biology and the last of the major ones to be ruled in. Think about what that means. Enceladus has liquid water, the right chemistry, an energy source, and it conveniently hoses its own ocean into orbit, where a passing spacecraft can taste it without ever landing. We haven't found life there, but we have found that its ocean is, by every measure we can apply, a place where life, as we know it, could live. Two more worlds round out the picture, and they are stranger still. Saturn's largest moon, Titan, has rivers, rain, and seas, but they are made of liquid methane, not water, under a thick orange sky. Anything living there would have to run on a chemistry unlike anything on Earth, which is precisely why a NASA rotorcraft called Dragonfly is being sent to fly across its surface and find out. And then there is Venus, our scorched twin, with a surface hot enough to melt lead. In 2020, astronomers reported a trace of phosphine in its clouds, a gas that on Earth is linked to life. The claim was immediately and fiercely contested. Years of follow-up have neither cleanly confirmed it nor cleanly killed it. Known non-living chemistry does not obviously explain it, but that doesn't make it life either. It remains a real anomaly hanging in the air of the planet next door, still unresolved. So put it all together. We haven't found alien life, not on Mars, not in the ocean moons, not on Earth. That's the honest headline, and it matters to say it plainly. But look at what has changed. A generation ago, the solar system looked like one living world and a row of dead rocks. Now we know there are oceans beneath the ice of at least 2 moons, that one of them is venting the very ingredients of life into space, that Mars was once habitable and still breathes a gas we cannot explain, and that we've barely begun to test even our own planet for life that doesn't look like us. The lesson of the last 20 years is not that we are alone. It is that the conditions for life are far more common than we ever assumed, and that our methods for finding it are far narrower than we like to admit. The nearest alien life may be waiting in a buried Martian rock, or in a plume of seawater off a moon of Saturn, or in a spoonful of mud on Earth that no one has thought to test the right way. We have spent centuries scanning the distant stars. The strangest possibility of all is that the first life we find will have been close the entire time.